There is a region of space so vast that you could pour the entire Milky Way into it and still hear the echo. It is a void, a place where the universe, which is teeming with stars, seems to have simply forgotten to exist. The sheer emptiness of it defies all logic, a silent contradiction in a sky full of light. We have mapped it, measured it, and stared into it, and the most startling discovery is this. Our best scientific minds can offer no reason for its existence. They admit, with a shrug, that it should not be there. So, what does it really mean if a space this enormous can exist without a single star, and what if it isn't as empty as we think? In 1981, a young astronomer named Robert Kirshner from Harvard University was leading a survey of galaxy redshifts across a small patch of sky when his team stumbled onto something that made them question their own equipment. They were mapping the distribution of galaxies, a routine cosmic census, yet in the region they were examining, they found almost nothing at all. The initial reaction was not excitement but suspicion, as they assumed a technical fault was hiding the galaxies from their detectors. After double-checking every reading and recalibrating their instruments, the truth settled in. They had just discovered one of the most peculiar structures in the universe. This void, which would come to be known as the Boötes Void, was identified by Kirshner along with Paul Schechter, Augustus Oemler Jr., and Stephen Schechtman during their redshift survey. Kirshner later described the region as a huge gap, comparing it to a piece of crumpled paper sitting in an otherwise completely empty room. Many scientists had to verify the data repeatedly because the results seemed too improbable to accept. When the discovery was published in the Astrophysical Journal, it made the front page of major newspapers around the world, including the New York Times. The implications were staggering because this single finding reshaped how humanity understood the large-scale architecture of the cosmos. You see, astronomers had mapped sheets and clusters of galaxies, but a region this vast with so few inhabitants defied their expectations. The sheer scale of the emptiness was hard to process, and even seasoned researchers found themselves struggling to believe what the numbers were telling them. So what exactly did they find, and was this place truly as empty as it appeared? The telescope operator leaned back in his chair, rubbing his eyes. He had run the calibration sequence 3 times that night. Each pass showed the same impossible result. The spectrograph's readings indicated that the targeted coordinates contained nothing but faint background noise. No hydrogen emission lines, no stellar signatures, no galactic cores. Just silence. Kirshner stood in the control room, staring at the printout in his hands. The paper felt warm and slightly damp from the humidity of the room. He ran his thumb across the jagged edge where the printer had torn it. His mind kept circling back to the same thought. This cannot be right. The region they had selected was supposed to contain dozens of galaxies based on earlier photographic plates. Those plates had shown faint smudges of light, which should have been entire systems of stars. But the redshift data told a different story entirely. Paul Schechter walked in with a fresh cup of coffee, the steam curling upward in lazy spirals. He looked at Kirshner's expression and immediately set the cup down on the metal desk with a soft clink. "What's wrong?" he asked. Kirshner handed him the printout without saying a word. Schechter studied it for a long moment, then flipped through the pages of the observation log. His fingers traced the columns of numbers, pausing at each entry. He went back to the first page and started again. The silence in the room grew heavy, punctuated only by the low hum of the equipment racks and the occasional click of the telescope drive mechanism. Augustus Oemler Jr. arrived later that morning, carrying a stack of photographic plates under his arm. He spread them across the table, angling each one toward the window light. The plates showed the same patch of sky, but the galaxies that should have appeared as distinct oval smudges were almost entirely absent. 1 or 2 faint specks appeared near the edges, but the central region was completely blank. Oemler shook his head slowly, his fingers tapping the edge of the table. He had spent years studying galaxy distributions, and this pattern did not match any known formation model. Stephen Schechtman suggested they re-observe the region using a different instrument. The team spent the next 3 nights pointing the telescope at hundreds of coordinates within the void. Each observation came back with the same result. The region was nearly empty, with only a handful of galaxies scattered across a volume that should have contained thousands. The numbers indicated that this volume of space, roughly 330 million light-years across, held fewer than 60 galaxies. For comparison, the same volume elsewhere in the universe would contain over 10,000. News of the discovery reached other research groups through informal channels. A physicist at Caltech reportedly laughed when he first heard the claim, assuming it was a practical joke. An astronomer from Princeton sent a letter demanding to see the raw data, writing that extraordinary claims required extraordinary proof. Kirshner mailed him a copy of the complete observation logs, complete with handwritten annotations and timestamps. The response came back 2 weeks later, containing only 2 sentences. The data is consistent. I apologize for doubting. The press coverage created a strange mix of excitement and confusion. Journalists struggled to explain the concept of cosmic voids to readers who had never heard of galaxy clusters. One reporter described it as a hole in the universe, which led to a wave of sensational headlines. Kirshner received calls from radio stations and newspapers asking whether the Earth was in danger. He patiently explained that the void posed no threat, that it was simply a region of lower density. But the questions kept coming. Yet the deeper puzzle remained unresolved. If the universe had expanded uniformly from the Big Bang, then matter should be distributed evenly across space. Gravity would then pull that matter together into clusters, leaving behind regions of slightly lower density. But the Boötes Void was not slightly lower. It was overwhelmingly empty on a scale that stretched the limits of theoretical modeling. Some researchers proposed that the void might have been created by the merging of several smaller voids. Others suggested that some unknown process had swept the region clean of matter. No one had a definitive answer. The theories multiplied, each one more complex than the last, but none of them fully explained the emptiness. So what exactly did they find, and was this place truly as empty as it appeared? There is an assumption hidden in the way we talk about this place. We call it a void, a name that suggests a total absence, a patch of sky with absolutely nothing in it. But the truth, as revealed by the painstaking work of a graduate student named Gregory Oldering, is far stranger than simple emptiness. In 1995, while working toward his doctorate at the University of Minnesota, Oldering decided to do something no one had done before. He dedicated months to mapping the entire region, using the 4-meter telescope at Kitt Peak National Observatory to measure the distances of every galaxy he could find within this supposed nothingness. What he built was a picture of a space that challenges our intuition. The Boötes Void spans an estimated 30 million light-years across, so immense it accounts for roughly 0.27% of the entire observable universe, a space equivalent to 236,000 cubic megaparsecs. To put that in perspective, you could line up over 3,000 Milky Way galaxies side by side and still not cross it. And yet within that staggering expanse, Oldering found only a few dozen galaxies. Not millions, not thousands. Just a handful of isolated islands scattered across an ocean of darkness. This is the core of the paradox that makes the Boötes Void so unsettling. The universe as we know it is a crowded place. Galaxies cluster together in great filaments, forming a cosmic web that connects everything. But here, in this particular corner of the sky, the rules seem to break down. The density of galaxies inside the void is roughly 1/10 the average for the universe, and at its very heart, that number can plummet to just 1/100th of the norm. Over 60 confirmed galaxies have been found in this region, along with wisps of interstellar gas and the ever-present shadow of dark matter. But that is an astronomically minuscule number for such a colossal volume. So when we say it is empty, we do not mean that there is nothing there. We mean that there is almost nothing there, a distinction that feels pedantic until you consider the scale involved. The absence is not a total void, it is a profound, almost unnatural scarcity. It is a patch of space where the very fabric of cosmic structure seems to have failed to weave its usual pattern. Think about what that means for a moment. Everywhere else we look, the universe is teeming with activity. Stars are born, galaxies collide, and energy flows across unimaginable distances. But in this region, spanning a distance it would take light 330 million years to cross, there is near silence. This is why the popular belief that nothing exists within the Boötes Void is a misconception. It contains at least 60 galaxies, and probably more that we have yet to detect, along with the cold gas and dark matter that thread through all cosmic structures. The difference is not existence, but density. It is the difference between a crowded city and a remote desert. Both are part of the same world, but they obey entirely different rhythms. And this desert, if we stretch the metaphor, is so vast that our minds struggle to hold it. If our own galaxy were the size of a coin, this void would stretch across a football stadium. Oldering's work, a doctoral thesis that took him months of patient observation, painted this picture in painstaking detail. He did not just look at the sky, he mapped it, measuring the redshift of each faint smudge of light to confirm their positions within this isolated region. The result was a confirmation of just how strange this place is. But here is the question that lingers, the one that makes scientists uneasy. If the universe's large-scale structure is a web, then this is a bubble in that web where the threads are almost invisible. Why would such a place exist? What cosmic accident or process could have swept this region so clean? We are looking at a space that is practically empty, and the more we learn, the more we realize that its emptiness is not a simple absence, but an anomaly that we are only beginning to understand. So what exactly do those rare galaxies look like as they drift alone in this vast, quiet expanse? This is the strangest part of the entire void. The galaxies that do exist inside this emptiness are not normal. They are almost all dwarfs, dim and small, and astronomers call them faint blue galaxies. According to the NASA Extragalactic Database, objects like PGC 455573112 and NGC 5600 are not just rare. They possess significantly less dark matter than galaxies living in dense, crowded clusters. It is as if the emptiness has stripped them of their most essential cosmic glue. The Hubble Space Telescope has peered into this darkness, and what it found only deepens the mystery. A study published in 2005 in the Astrophysical Journal analyzed 21 galaxies within the Boötes Void and discovered something unexpected. They are older, they form stars far less actively, and their shapes are abnormal. They do not display the elegant spiral arms we see in the Milky Way. Instead, they are irregular, lumpy, and seemingly unfinished, frozen in a state of arrested development. This is not what a healthy galaxy should look like. This is what a galaxy looks like when it has been left alone for far too long, without the cosmic interactions that trigger new generations of stars. Robert Kirshner, the man who first stumbled upon this emptiness, had his own poetic way of describing it. He called it a string of isolated galaxies on a dark region, and the galaxies themselves have earned a nickname, fireworks galaxies. They flare brightly against the blackness, but they are utterly alone. They are not part of a grand cosmic dance. They are solo performers on an empty stage, and their performance is brief. But the most haunting story is that of NGC 5600, which sits right on the edge of the void. This is not a galaxy living in quiet isolation. It is a galaxy in the middle of a violent merger, colliding with a smaller companion. This collision is triggering intense bursts of star formation at the very boundary of the emptiness. It is a dramatic, fiery event happening right at the edge of the abyss, as if the universe is trying to create something new where everything else has faded away. Astronomers study it intensely because it shows us what life is like on the rim of nothingness. And the strangest part? The numbers are undeniable. A 2019 study in the monthly notices of the Royal Astronomical Society, which examined over 300 galaxies inside the void and its immediate surroundings, found that star formation is suppressed by roughly 20 to 30% compared to galaxies in normal environments. The sparse environment itself is the culprit. It is not that the void is empty, it is that the void actively prevents things from growing. It is a cosmic nursery that has been abandoned, leaving behind only the smallest, oldest, and strangest residents. These galaxies are not just sparse, they are fundamentally different. The emptiness has not just taken away their neighbors, it has stolen their future. They are like living fossils drifting in the dark, and every single one of them is a clue. So, what created a place this bizarre? What could possibly carve out such a vast, oppressive silence in a universe that is otherwise so full of light? Hubble's deep-field images of this region reveal galaxies that are not just old but malformed, their disks warped or torn by ancient gravitational encounters that never completed. They lack the crisp, elegant spiral arms seen in denser clusters, appearing instead as smudged, irregular blobs of pale blue light. This light is ancient, traveling for billions of years before reaching our detectors, carrying with it the story of a slow, lonely death. The faint blue hue, so characteristic of these dwarfs, is a ghost of past star formation, a final flicker before the cosmic fire dies out completely. Take PGC 455573112, a galaxy so dim that it barely registers against the backdrop of deep space. Its total luminosity is less than 1% of our own Milky Way, yet it clings to existence with a gravitational grip that suggests a hidden mass we cannot see. It holds only a fraction of the dark matter that anchors galaxies in crowded neighborhoods, making its structure fragile, almost transparent, as if a strong cosmic wind could tear it apart. This deficit in dark matter is the key, for without that invisible scaffolding, a galaxy cannot pull in the gas needed for new stars. It is a skeleton without muscles, a body that cannot move or grow, forever frozen in a state of half-formation. The sparse environment has starved it of the very substance that gives galaxies their weight and purpose. This creates a disturbing paradox for astronomers. The void was supposed to be simple, a blank slate. Instead, it is a laboratory of extremes where the galaxy merger NGC 5600 becomes a violent exception. It defies the quiet stagnation of its neighbors, erupting with intense star formation at its edges where the smaller companion is being shredded. Why is this one galaxy so active while the others slumber? The answer might lie in the collision itself, the only source of fresh fuel in a desert of emptiness. It is a brief, brilliant firework in a sea of eternal night, a testament to the fact that even in nothingness, gravity can still force a spark of life. The Hubble data from 2005 confirms that these bursts are localized, confined interaction zone, leaving the rest of the galaxy untouched and ancient. Robert Kirshner's poetic description of fireworks seems almost too kind. These explosions are not celebrations, they are the final gasps of a dying system. So how do you actually build a region of space that's empty? The answer, according to modern cosmology, is surprisingly mundane, and it starts with the standard model of the universe, the Lambda CDM model. Data from the European Space Agency's Planck satellite, gathered from the cosmic microwave background, supports this framework, and the story it tells is one of gravity's patient, relentless work. In the aftermath of the Big Bang, the universe was a nearly uniform, hot soup of matter and energy, but it wasn't perfectly uniform. There were tiny quantum-scale fluctuations, regions that were ever so slightly denser or sparser than their surroundings. Then gravity took over, ruthlessly amplifying those minuscule differences. The slightly denser patches exerted a stronger gravitational pull, drawing in more matter and becoming even denser, while the sparser patches, offering less attraction, were gradually abandoned as their material was siphoned away by their more massive neighbors. That is the core mechanism behind cosmic voids, and the Boötes Void is an extreme consequence of this process. As the denser regions collapsed into the massive structures we call galaxy filaments, the material between them was pulled away, leaving behind great expanding emptinesses. The popular hypothesis, once supported by Robert Kirshner himself in his book The Extravagant Universe, from Princeton University Press, is that Boötes is not a single primordial void, but rather the product of several smaller voids merging together. This is a natural evolutionary process, not a freak event. Over billions of years, as the universe expanded and structure grew, these smaller empty regions, with their own weaker gravity, would have gradually converged, their boundaries dissolving to form the colossal, elongated emptiness we observe today. It's the cosmic equivalent of soap bubbles merging into one larger bubble, a simple self-organizing principle at a scale we can barely comprehend. But the story does not end with a simple explanation. Precision simulations like Illustris TNG and the Millennium simulation, produced by teams like the Max Planck Institute for Astrophysics, offer a more complex and frankly more unsettling picture. When cosmologists run the numbers, they find that these voids are not static, empty spheres. They are dynamically evolving, almost living structures. The simulations show these regions tend to be roughly spherical but with fuzzy, ill-defined boundaries, and as time goes on, they do not just stay empty, they actively swell. The gravity of the surrounding galaxy filaments continues to pull material out of the void's interior, making it larger and, at the same time, more profoundly empty. This is a key insight, but it still feels tidy, maybe too tidy. So what does this mean for the Boötes Void specifically? It firmly places it as a predictable outcome of the universe's large-scale structure, a web of matter where vast filaments connect dense clusters and enclose enormous empty spaces. The Sloan Digital Sky Survey, SDSS, helps put this in perspective, showing that voids like Boötes are not rare anomalies, they are the universe's dominant feature. They occupy about 80% of the volume of the observable universe, yet they contain only about 10% to 20% of the galaxies. That means this nothingness is actually the default state of the cosmos, and the brilliant star-filled regions we inhabit are the exception, the glittering threads in an otherwise empty tapestry. The concept of these voids has a long, interesting history that further normalizes the Boötes Void. The idea was first predicted on theoretical grounds back in the 1930s by the astronomer Fritz Zwicky. He was largely ignored for decades as his ideas seemed too radical. It wasn't until the large-scale redshift surveys of the 1980s, powered by new technology, that his predictions were spectacularly confirmed. Astronomers were suddenly mapping the universe in 3 dimensions for the first time, and what they found was a massive, frothy structure of clusters and filaments, with Boötes as one of the first and most dramatic examples of the voids between them. So, the discovery was not a glimpse into some cosmic anomaly, it was a confirmation of a grand previously untested theory. The universe is structured as a great cosmic web, a predictable outcome of physics acting over 13.8 billion years. But here is where the tidy narrative starts to unravel. The standard models can explain the existence of voids, but when they try to replicate Boötes Void's specific scale and depth, they encounter a problem. It is simply larger and emptier than the models predict should be common. The sheer size of it, that 333 million light-year stretch of near-nothingness, is right at the very outer limits of what the leading theories consider possible. So while we have a general explanation, it's a bit like explaining why a hurricane forms, without being able to predict why one particular storm becomes a Category 5 monster. The physics seems right, but the specific, extreme outcome feels like it owes something to chance, or perhaps to something else. But if the explanation is so simple, why is there still so much debate? Here is the script for Part 6, written in English, following the detailed outline and constraints. 40 years after its discovery, there is still no single universally accepted explanation for the Boötes Void's exact formation. The leading ideas point to a merger of smaller voids, the influence of primordial density fluctuations, or a complex interaction between dark matter and dark energy, a summary of the scientific consensus from the Annual Review of Astronomy and Astrophysics in 2021. But some explanations go far beyond conventional cosmology, and this is where the story takes a strange turn. In 2020, physicist Laura Mersini-Houghton of the University of North Carolina proposed an idea that divided the scientific community, that the Boötes Void might be a quantum imprint from another universe. This dramatic theory, published in the European physical journal C, was met with both praise for its boldness and criticism for its lack of observational evidence. But wait, the controversy doesn't end there, because the void might be connected to one of the greatest mysteries in modern cosmology. Could this empty region be responsible for a strange cold spot in the cosmic microwave background? Data from the European Space Agency's Planck satellite in 2013 revealed a region in the southern sky that is significantly colder than its surroundings. Some scientists, including a team from the University of Hawaii, suggest that a massive void, possibly the Boötes Void itself, is eating the energy of photons as they pass through. This would explain the temperature difference of about 70 microkelvins, a phenomenon that has no firm solution. This would also mean that a void is not just a passive emptiness, but an active participant in shaping our view of the universe. Here is another strange fact. In more than 4 decades of research, no one has ever found a void that is more empty than the Boötes Void at the same scale. This makes it a true outlier in the cosmic map, challenging astronomers to constantly revisit their models of cosmic structure. So what are we to make of these unresolved questions? How can we ever hope to decode a structure that defies our standard models? The theoretical drama intensified in 2020 when physicist Laura Mersini-Houghton from the University of North Carolina published her bold proposal in the European physical journal C, suggesting that Boötes Void is not merely an accident of merging smaller bubbles but a physical scar left on our universe by a collision with a parallel one. Her argument hinged on a mathematical model of quantum entanglement across cosmic horizons, positing that the void's extreme emptiness mirrors the gravitational shadow of a neighboring cosmos. The paper ignited immediate conflict. One group of theorists applauded the audacity of connecting galactic-scale emptiness to the multiverse, while another group dismissed it as numerology dressed in high-energy physics language. At a virtual conference that autumn, a heated exchange captured the essence of the dispute. Dr. Mersini-Houghton defended her interpretation with a question that hung in the static of the video call. If the void is not imprint, how do you explain its alignment with the anomalous cold region in the sky? A senior astronomer from Princeton countered, his voice dry and cautious, noting that observational bias and dust extinction could mimic the same temperature dip across many independent sky patches. No one, however, offered a clean alternative test that could separate her prediction from a simple void model. Meanwhile, the team from Hawaii ran simulations that fed on the Planck data, looking for the exact geometric signature of photon energy loss along a straight line of sight through Boötes Void. Their models showed a marginal match, but the uncertainty bars overlapped so heavily that they could not claim a definitive absorption path. The more they tweaked the void's density profile, the more the solution seemed to stretch into a shape that no theoretical void should hold. A low hum of tension filled the laboratory as the lead analyst stared at the screen, muttering that the numbers were both beautiful and unreachable. Other researchers probed the void's internal galaxies, hunting for a distortion pattern in their velocities that might reveal a hidden mass component, maybe a clump of dark matter tied to a string defect from the early universe. They found no coherent motion, no dynamical coldness, just a quiet stillness that made every standard formation model feel incomplete. The cold spot in the cosmic microwave background remains stubbornly attached to the void's location, yet the causal link stays fuzzy, a statistical whisper instead of a roaring proof. Every proposed mechanism carries a flaw that a skeptical colleague can exploit within minutes. Standing at the edge of this epistemic cliff, one cannot help but feel a mix of awe and frustration. The void is real, sharp-edged in maps from distant redshift surveys, but its origin is as slippery as an apparition. Why should this single emptiness, more than any other large void, resist every explanation that fits elsewhere? The universe is supposed to be smooth at large scales, yet here sits a hole that mocks that expectation. How can we ever hope to decode a structure that defies our standard models? So how do you even begin to make sense of something that swallows 330 million light-years of space? The answer is you bring in the most powerful eyes humanity has ever built. The James Webb Space Telescope, with its deep infrared vision, has already been scheduled to turn those eyes toward the galaxies hiding inside Boötes Void. The proposal database from NASA and the Space Telescope Science Institute shows observation cycles dedicated to studying how galaxies form and evolve in environments so incredibly sparse, and the hope is that Webb can finally reveal what the void has been keeping secret for billions of years. But Webb is not the only instrument joining the hunt. On the ground in Chile, the European Southern Observatory is constructing the extremely large telescope, a beast with a primary mirror measuring 39 meters across, and when it comes online it will be the largest optical telescope on the planet. Its sheer light collecting power is expected to let scientists study the faintest galaxies within Boötes Void in detail we have never managed before, effectively opening a new era of research into what some researchers now call dead space. You have to appreciate the irony here. We are building bigger and bigger machines to look at a place defined by emptiness, and every new instrument seems to make the void more interesting rather than less. Radio astronomy has already added its own strange chapter to the story. Surveys like the Australia Telescope Large Area Survey, run by CSIRO, have combed through the region and found that Boötes Void is almost completely silent in radio frequencies. There are no strong signals from quasars, no active galactic nuclei blazing away, no dramatic outflows of energy, and that electromagnetic quiet makes it radically different from the crowded parts of the universe. It is as if the void is not just empty of light but empty of noise too, a silence so profound that it becomes a clue in itself. Then in 2022, something unexpected happened. Study using artificial intelligence to scan data from the Sloan Digital Sky Survey automatically identified 43 new cosmic voids, and among them was one is even larger than Boötes Void. But because that particular region sits in a direction obscured by the Milky Way, astronomers cannot study it properly, so Boötes Void remains the most famous and the most scrutinized empty space in the known universe. That feels almost poetic, doesn't it? The biggest hole we can see is still the one we know best. Now here is how you wrap your head around the sheer scale of the thing, because honestly, the numbers can feel abstract until you frame them right. Start with the basics. The void stretches 330 million light-years across, which translates to roughly 3.1 million trillion kilometers. And if you had a ship traveling at the speed of light, it would take you 330 million years just to cross from one side to the other. Let that sink in for a moment. That is not a drive across town. That is a journey longer than the entire history of complex life on Earth, repeated more than 70 times. Make it more tangible, imagine the Milky Way, our entire galaxy with its 100,000 light-year diameter shrunk down to the size of a coin. In that same scale, Boötes Void would be as wide as a football stadium. And when you multiply out the volume, you get more than 35 billion cubic light-years of space. Enough room to hold thousands of galaxy clusters like Virgo. Yet in reality, it contains only a few dozen scattered galaxies. That is the kind of emptiness that makes your brain briefly stutter. Put it in perspective against the observable universe, which spans about 93 billion light-years across, and Boötes Void takes up roughly 0.27% of the entire volume we can see. It is a tiny fraction of everything, and still it is large enough to swallow thousands of galaxies whole. You can even check this yourself if you are curious. Tools like the NASA Exoplanet Archive or Google Sky let you zoom into the constellation Boötes and look for the faint smudges of light that mark the galaxies living on the edge of the void. It takes a little patience, but once you see them sitting there in the dark, isolated and alone, you start to understand why scientists keep coming back to this place. These instruments are not just tools for observation, they are fundamentally reshaping how we understand the universe. The Boötes Void does more than just sit there looking empty. It actually pushes at the foundations of our most successful models of the universe, forcing cosmologists to question whether their simulations truly reflect the reality of the cosmos. For instance, a theoretical study published in 2020, championed by Professor Adam Reyes of the Space Telescope Science Institute, suggests that our measurements of the Hubble constant, the rate at which our universe is expanding, might be distorted. These colossal voids, with their immense gravitational pull, act like giant gravitational lenses, bending the light and affecting the very measurements that tell us how fast everything is flying apart. So this emptiness isn't just a passive absence, it's an active participant, skewing our view of one of the most important numbers in all of modern physics. And its influence stretches even further, quite literally all the way to our own galactic home. Some astrophysicists, like R. Brent Tully from the University of Hawaii, have proposed that the enormous expanse of the Boötes Void is a key player in the mad dash of our galaxy. They argue that this region of profound emptiness exerts a kind of repulsive force, a push from the void that, combined with the pull of the dense great attractor, helps explain why our Milky Way and its neighbors are rushing through the cosmos at roughly 600 kilometers per second. We're not just drifting in the dark, We are being shunted along by the very architecture of this vast emptiness, a thought that truly reframes our understanding of our own cosmic journey. But is the void, this supposed agent of cosmic influence, truly just a featureless empty expanse, or does it hide a secret texture of its own? Beneath the apparent nothingness lies a surprising discovery from 2017, when the Herschel Space Observatory found a substantial amount of cold molecular gas and dust lurking deep within the void. This hidden material suggests the area isn't a perfect vacuum but a realm of subtle structure, potentially cradling undiscovered clumps of dark matter. Furthermore, a 2021 simulation involving over 1 billion particles revealed that voids like Boötes might be threaded with faint cold filaments of this elusive substance, home to galaxies so tiny and faint that our current telescopes simply can't spot them. We are only beginning to perceive the intricate, ghostly anatomy that fills this apparent void. The question then becomes, how does this anomaly fit into the grand standard model of everything? This is where Boötes Void becomes a true headache for cosmologists, because it's roughly 3 times wider than the largest voids that the most sophisticated standard cosmological simulations can generate. This is a direct challenge to the lambda CDM model, the prevailing framework for our universe, which suddenly appears incomplete if it can't replicate such a massive, defining structure. This mismatch between observation and theory is not just a minor discrepancy, it's a glaring sign that our understanding of cosmic evolution is fundamentally incomplete. Yet we cannot simply write it off, which is why Neil deGrasse Tyson, the famed astrophysicist and director of the Hayden Planetarium, often cites the Boötes Void as a humbling reminder of our scientific limitations. To truly appreciate its impact, we can look at the void not as a mere scientific puzzle, but as a mirror for our own intellectual journey. Imagine the universe as a giant cosmic sponge where the empty holes are these vast voids and the denser sponge material represents the great filaments of galaxies. Gravity is the master sculptor, pulling matter away from the empty spaces and weaving it into the dense structures we see today. A process that unfolds over billions of years, with the universe we observe being but a single frame in a continuous, ever-evolving story. And on a more personal level, we can find an odd comfort in this emptiness, understanding that just as the universe needs these spaces to create structure, our own lives require moments of quiet, which are not signs of failure but essential for concentration and growth. So, the next time you look at that seemingly empty patch of sky, you might ask yourself, if you were a scientist faced with the profound silence of the Boötes Void, what would you search for within its infinite dark? Min, a 35-year-old programmer in Ho Chi Minh City, used to end his exhausting days by watching space documentaries. One evening, a video about the Boötes Void left him with a strange sense of relief, because if the universe itself has empty spaces, then perhaps his own periods of burnout and emptiness are natural too. Science, after all, is an act of humility, and Neil deGrasse Tyson, the director of the Hayden Planetarium, has pointed to the Boötes Void as one of the greatest examples of that. It reminds us that there is so much we still do not understand, and that is not a failure but an invitation. Some people speculate that this enormous emptiness might hide a supermassive black hole or an invisible cosmic wall, yet no observation from the Chandra X-ray Observatory or any other telescope has ever supported such ideas. The standard models of astrophysics still hold, and the void remains a quiet, unexplained chapter in our cosmic story. We started with the image of a scrap of paper in a completely empty room, and maybe that image is the most honest one we have. But here is the thing, that empty room is not truly empty, it is full of dark matter and faint galaxies and cold gas, just as our own silences are full of unspoken thoughts and quiet growth. The Boötes Void does not ask us to fear emptiness, it asks us to look closer. Have you ever considered that the empty spaces in your own life might be holding more than you realize? Then perhaps the void is not an absence but a threshold. Ong Min, a 35-year-old software engineer in Ho Chi Minh City, scrolls through space documentaries after 12-hour shifts, his eyes dry and his shoulders tight. When he first watched a video about the Boötes Void, he expected awe or fear, but what surfaced was a strange lightness. He told a friend later that if the universe can hold a space so vast and so empty, then his own tired evenings, his quiet rides home on a crowded bus, his moments of staring blankly at the ceiling, they all fit into a larger pattern. That recognition did not solve his exhaustion, but it softened it like a cool hand on a fevered forehead. He began to see his own emptiness not as a broken thing but as a necessary pause, a blank margin in the dense manuscript of his days. The void taught him that not every moment needs to be filled, and that admission alone changed the texture of his nights, the way he sat with his coffee before the screen flickered to life. Science, in its quietest form, had given him permission to rest, and that rest felt like a quiet rebellion against a world that demanded constant motion. We do not know what the Boötes Void truly is, and that uncertainty is not a gap in our knowledge but a door left ajar. The same could be said for the hollow places inside us, the ones we avoid naming. Perhaps those silences are not waiting to be filled but to be listened to. The scrap of paper in the empty room does not need to be rescued, it needs to be noticed, and in that noticing, the room comes alive. So what would happen if you stopped measuring your worth by what you produce, and started paying attention to what you simply hold, quietly, in the dark?